Today we're going to look at linear equations. It's a funny name, linear. Why do we call it linear? Linear, believe it or not, actually means straight. So clearly this is going to make a straight line graph. We actually graph these on what we call our Cartesian plane. This Cartesian plane consists of two different sets of axes. It has the x-axis that runs from left to right. It also, you could say, that it runs horizontally there as well. We have the vertical axis, which is the y-axis. Now notice x always becomes before y in the alphabet, x, y, z. So therefore, when we're actually listing the numbers as coordinates, we're going to list the x-axis, the x position before y. So it's a bit like battleships. So for example, if I want to know what this point was here, I just need to read off both of the axes. I can see that it intersects between 6 and 4. If I draw straight lines out from there, I can see that the coordinate here then is going to be 6, 4. And we always put those in brackets as well, just to show that that is actually a coordinate. Another word for these are ordered pairs, and that just really means that it tells us which position or location this point is on. You'll find that every single coordinate located in this area will be positive for both the x and y. Obviously, it's going to be positive for the x and it's going to be positive for the y. This is typically referred to as the first quadrant. Alternatively, not alternatively, but next, moving weirdly in an anti-clockwise direction, is quadrant 2. In this quadrant, this one here, you'll find you'll have negative x coordinates and positive y coordinates. So this coordinate here would be -6, 2. Because I can read off this point, I can see that it comes up from -6, and on the y-axis it is 2. It gives me the location there. Moving around naturally in the anti-clockwise circle, we've got the third quadrant down here. In this third quadrant down here, you're going to find that you will have negative x's and negative y's. Lastly, with the fourth quadrant, you will have positive x's and negative y's. One other point that we haven't mentioned that it does definitely need some mentioning is this point right in the middle. We call that the origin. It is the origin of everything that's graphed from the Cartesian plane. I suppose some people may say all graphs originate from here. That just gives us our starting point. So it's an origin from here. That coordinate is 0, 0. Moving across changes our x-axis, and moving up and down changes our, y positioning. So anywhere from our origin is really mapped out how many steps I'm moving to the left or right, and how many steps I'm moving up or down. So if I move 2 to the right and 3 up, I'm going to find that that point right here actually has the coordinates of 2, 3, because it's measured from the origin. 2 on the x-axis from the origin and 3 up. So that's how we actually measure these points on the Cartesian plane. Some other points of interest are any points on the actual y-axis. So if we look at this one for a moment, we're just going to list out a few points. So as you can see, all the points on this y-axis actually start off with an x-coordinate of 0. Now that makes sense. Obviously, when we're mapping these, we have the origin 0, 0. I've just moved 6 points up, so I haven't moved left or right. So I'm still on 0, 6. This point here is 0, 5. This point here is 0, 4. So what we can see is that even at the origin, we've got 0, 0. And down here, it's going to be, whoops, I've done this one wrong, should be, and that's a very common mistake, 0, -2, because we list the x position followed by the y. So as you can see, everything on the y-axis actually has an x-coordinate of 0. This comes in handy when we're going to actually find out how to find the y-intercept of specific equations. So if we create a table of values and we actually substitute in x equals 0, we'll find out for this equation what the y-intercept is. So we've just created a table of values. Clearly, this is a table because it looks like it, and it has values. Hence, we call it a table of values. It is plural because every x we have to put into the equation, we have to find out where it's going to map to. So when x equals -3, if I substitute this into the equation, and when I say substitute, I mean literally like basketball or your favorite sport, off comes one person, on comes the next. It's called a substitute. So we're going to substitute for x, -3. So this reads 2 times x minus 1. So we're going to substitute x for -3. 2 times -3 gives us a value of -6 minus 1. That will give us a value of -7. Clearly, that will be what y equals. We put that value in our table of values to actually help fill it out. We're going to do these for all of these and substitute them in. We substitute -2 in. 2 times -2 is -4. Minus 1 is -5. We need to put that value again in our table of values. 2 times -1 is going to give us -2. Minus 1 will give us -3. So we keep on filling in the table of values for that too. Finally, we've came up to our y-intercept value. Don't forget that what we talked about earlier was that everywhere on the y-axis has an x-coordinate of 0. So if we substitute in 0 in for x, you'll find that it actually gets rid of this whole term because I've got two lots of nothing minus 1. So you're just left with -1. So therefore I know on this graph that the intersection where this graph will go through here, because when x equals 0, y will equal -1. I can actually plot out all these other points because these are actually coordinate points when I substitute them in. And we can find out and you'll see what the graph will start looking like. So here you can see I've already plotted the 3 points and it's actually going to be a straight line. We can see that's going to go through all of them. Let's keep on figuring out the rest of the values. 2 lots of 1 is 2. 2 minus 1 is just 1. 2 lots of 2 is 4. 4 minus 1 is 3. Notice the whole time we're still following the rules of BIDMAS as well, doing my multiplication and division before I do my addition and subtraction. 2 lots of 3 is 6, and 6 minus 1 is 5. Notice each time as we go up by x by 1, it's actually growing by 2 in the y. It goes up by 2. Why is that? Because every time when you're actually putting on increasing the x value by 1, you're actually putting another group of 2 in. So we can plot all these points on here. Now we've substituted these in. It tells us, and maps out where the two values are, because that's the beauty of the Cartesian plane. It shows the relationship between two variables. And as we can see, as we talked about, if we increase x for every 1, it's going to go up by another group of 2, because obviously what y will equal, if you're putting x up by 1, you're putting another group of 2 in. So we're going to see that goes up by 2 every time we go across by x by 1. So y will increase by 2 as we go up across by x by 1. This here, as you can see, if we actually put a rule on there, you'll find it will make a straight line, like so, as we put on Desmos. As you can also see, this actually goes through all these points that we've actually mapped out already. Which is absolutely fantastic for us because we've mapped it out quite right. So from this table of values, we can see what the y-intercept is. We can clearly see that the y-intercept here is when the y-intercept is when x equals 0. We can see -1. However, we haven't quite figured out what the y-intercept is. We figured out what that is when x is 0, y equals 1, because we know, don't forget, on the y-axis all coordinates have all x coordinates are 0. If we look at the x-intercept and we want to know what the value of that is, well, if you think about what every y-coordinate here is, it will be 0. At this point here, we have -4, 0, here 4, 0, here 6, 0. So you can see the x-coordinate changes, but obviously the y-coordinate is always going to be 0 because anywhere on this line, the y positioning is 0. So how can we actually find the x-intercept here if it doesn't come up in the table of values? We can look for, well, when y is 0, but we don't have it. Hopefully you can see that the average point here, if there was y0, it would be at x equals 0.5. So you could graph it and you could try and read what this point is. But another way is you know that y has to be 0. So what we're going to do is we're going to equate the equation and let y equals 0 to find what the x-intercept is. So we let y equals 0 for the equation. Let y equals 0. So 0 equals 2x minus 1 because that's part of the equation here. Why am I letting y equals 0? Because if I let y equals 0, it's going to tell me what the x position here is. Now if we solve this, we can actually add 1 to both sides. 1 equals 2x. And now we can divide by 2 on both sides, and you're going to find that x equals 1/2, which is great because we sort of could see just from this pattern, obviously, to get to 0 on y, it's halfway between -1 and 1, and halfway between the x-coordinate of 0 and 1 is 0.5. So therefore now we know that this coordinate is 1/2. You can either write it as a fraction or as a decimal. It really doesn't matter, but you should be consistent. You shouldn't write fractions and decimals throughout the actual graphing. So if you go with fractions, go with fractions. If you go with decimals, just do decimals everywhere. So now we actually figured out what the x-intercept is and what the y-intercept is. Really, all you need to do and graph these linear equations is just actually have 2 points. You only need to find 2 points, and then you can do a straight line between them. I mean, if you've got 2 points, or you've got 5 or 6, like what we've got here, obviously they're going to go through them all because it's a straight line. It doesn't matter which 2 points I use. I can substitute in any x value and find the y-coordinate for that, put a point here, and put another point anywhere else, and I can actually just draw a straight line through those. Alternatively, what we can do is you can actually find the x-intercept by letting y equal 0. Another way you could actually find the y-intercept is, well, we know that with the y-intercept, x always equals 0. So if we actually let x equal 0, we can do a very similar thing that we just did here to actually then find what y will equal. So we have y equals 2 times 0 minus 1, and if you go 2 times 0, well, that's just going to always be 0. Y equals -1, which will tell us where our actual y-intercept occurs on this graph. So we can see there, it's at 0, 1. Another thing you might realize is, well, hang on a moment, it is always the y-intercept is just going to be this constant number at the back, as long as it's written in the format of y equals a number, let's give that m, times x, plus or minus a number on the end here. We're going to give that c. Well, if you think about it, if your x equals 0, 0 times any number is going to give you nothing, and you're just going to be left with this constant number at the back. That's why we call it a constant number. I mean, it's always there. And that actually is also another way to show where your y-intercept is. I hope you enjoyed this video. Hopefully we can have a quick look at this one again. Just to quickly summarize up on where we went, don't forget the Cartesian plane, we use 2 points to determine where they are. We always say the x first, this axis, with the y coordinate next. It's where they meet, those 2 points. Actually is what we defines where it's located. 3, 5 for this one, 3 on the x and 5 on the y, and that's measured from the origin. You can, with an equation, you can create a table of values. You only need 2 points, and as long as it's a linear equation, and then you can just draw a straight line between those two. We create these table of values, we substitute in the values for x into the equation. Don't forget, we call it substitute because off comes x and on comes a number. To find the y and x intercept, well, there's a couple of ways. You can look at it from the actual table of values, and you know when x equals 0, we know that obviously that's going to be our y-intercept -1, because x equals 0 anywhere along here. We then can try and look for when y equals 0. Along the line here, we know that y is going to be 0, and that will tell us where our x-intercept is. In this case, we didn't have it, so you can actually let y equal 0 and then solve the equation algebraically to find out where that x-coordinate is, and it is a half. Another way we can actually find the y-intercept is also to let x equal 0. When you do this, you can find the y-intercept. Alternatively, if it is written in y equals mx plus c format, or y equals ax plus b, or anything like this, you can see this constant number on the end is going to be the y-intercept. So you can always rearrange your equation to be y equals number times x plus a number, or plus or minus a number on the end, and that number there will be where your y-intercept is. Good luck with linear equations. There is a lot to it. We touched a little bit on the gradient as well, talking about the rise and run. The gradient really just does come from this number out the front. This number just increases the y by every time when you increase x by 1. So we'll touch on that a bit later. But for now, there's a lot in this video. Good luck. Have fun with linear equations. I'm sure you can do well.